and Josh will be doing an experiment that deals with showing that the that changes in temperature can affect the elasticity of a rubber band. Particularly, that a cold rubber band will be more elastic than a warmer rubber band. And to do this, we have 3 rubber bands of 3 different temperatures. One is going to have been in the oven, one is going to have been in the freezer, and one is going to be at room temperature. And for all of them, we have a fish scale, and we will put the rubber bands on the hook side of the fish scale and pull it down, and then we will compare the temperature to determine which one is which one is the most elastic.
Okay, so I'm going to be testing the room temperature rubber band with the fish scale now, and I'm going to pull it until it breaks. Oh my. Okay. Alright, this rubber band took 23 and a half pounds of pressure to break. And yeah, that hurt. Alright. Okay, now we're going to do the warm rubber band and see how much it needs to break.
What?
That was quicker. Alright. As you can see, the warm rubber band only took 13 pounds of pressure to break. Okay, we are going to be doing the last rubber band, which is the cold rubber band that's been sitting in the freezer for about 3 to 5 hours now. Yeah, 3 to 5 hours. And I'm going to be seeing how much it takes to break this rubber band. So, here we go. Oh, it's hard. I couldn't even stretch. And as you can see, it took 32 pounds of pressure to break the rubber band. Wow. Okay. Thank you for watching. This was Ethan and Josh's physics experiment.
So today we'll be showing how much gravitational potential energy this tennis ball will have at the top of a flight of stairs, or half a flight, however much, by rolling it down the stairs. And it is the only way that this will work is if the gravitational potential energy transforms into kinetic energy. And we're also going to roll it down from half of the height. And at the bottom, we're going to measure the distance that it rolls. And then we're going to compare those numbers to determine whether this tennis ball will have had more gravitational potential energy at the top of the stairs or halfway down the stairs.
Okay, so what we're going to be doing is measuring how gravitational potential energy changes with height. And the way we're going to be doing this is using stairs. As gravitational potential energy goes up, when we roll the balls down the stairs, they go straight to kinetic energy. And since no energy is lost in an energy transfer, we should be able to measure gravitational potential energy by the use of kinetic energy. So, here we go. We're going to be using the 3rd step and the 5th step in this experiment. And here's the 5th step. And that far. And here's the 3rd step. It went that far. And now we're going to be measuring the distances they went from the stairs. So, the first one went exactly 2 yards. which is about 90 centimeters, give or take. The next one went about 6 yards and 3 centimeters. So, that is our second experiment, which is measuring gravitational potential energy using kinetic energy.